Okay, dear student, let's see what is there in this question. An ideal gas is in container with a movable piston. The piston compresses the gas rapidly. Now, this word is very important. Like you can compress the gas, but here the gas is compressed rapidly, like this. The temperature of the gas increases. Why? The molecules bounce off. Of course, the temperature of the gas will increase. PV is equal to nRT, and like you know what is happening in adiabatic process, what is happening in other processes. So of course, when such a kind of thing happens, it usually acts like adiabatic process, by the way. So the temperature will be increasing there. Now the question is, from the micro level, from the molecular level, why the temperature is rising when you are doing that. So the molecules bounce off the piston with increased speed. So now the molecules are having bigger speed and they're heating. Well, that should be the correct answer probably. I would be reading other options also. Why? Because temperature is only and only related with the kinetic energy of the molecule, that is the speed at which the molecules are moving. So if you say that temperature is increasing, clearly the speed is increasing and the kinetic energy is increasing, no doubt about it. So A should be the right answer. But let us go for B, C, and D and try to understand why are they wrong. B, the molecules collide with piston more frequently. Well, technically speaking, yes, even this is right, that the molecules, they will be colliding more frequently. Why? Because now they are occupying the lesser space, so of course they will be colliding more frequently. But is that the reason for increasing the temperature? I don't believe so. Might be in pressure, we can assume, but even in the pressure, no. Because from the theory, the ideal gas theory, what we have is 1 by 3 rho V square. That is the formula for the pressure. And you can see that there is nothing there for frequency or like the time of the collision or something, that is not required here. So this thing is not happening. So pressure is also not connected with the frequency anytime. So B is not the right answer. Now going for the C. Molecules exert a greater force on piston. Molecules exert a greater force. Well, that is actually the right thing. Why? Because they are moving with more speed, and because of the more speed there is more momentum, and the collision is taking place and there is a change in momentum. Of course there is more force. Molecules exert a greater force on piston. I can only say that given this condition, that the ideal gas is in a container with a movable piston, the piston compresses the gas rapidly. So you are actually talking about a certain context. So even this is not wrong. The pressure will be more. There is no doubt about it. The pressure is going to increase. So if the pressure is increasing, it means that the force has increased. So these are very near kind of options, I would say. So molecules exert a greater force, but it's not about the force, like it's actually about the collisions which are taking place at the higher speed that increases temperature. So this is, practically speaking, this is right, this is also right, but they are not related with the temperature. The number of molecules per cubic meter has increased. Now even this is correct, isn't it? Because the volume has reduced, and so of course the density is higher, so there are more number of molecules per cubic meter. That information is correct, but again it has nothing to do with the context mentioned here, nothing to do with the temperature. That is why D is also wrong. So this is one such a question, I would say, that all the options, they are all correct, and still you have to choose the best out of these four. So it's no more this is correct and other threes are wrong. It is this one is best and other threes, they are right, but they are not the best. Okay, dear students, this is Professor Varun. I hope you like the video. Please like and subscribe to the YouTube channel and watch the next video. All the best. Bye.